Hi everyone. Welcome to my channel. Ocean discovery complicates plans to slash climate pollution. The ocean's ability to absorb industrial CO stopped keeping pace with emissions in the 1990s. Here's what may have happened. Scientists have struggled for decades to explain a climate mystery as deep as the ocean. Oceans have absorbed almost 40% of carbon dioxide humanity has emitted from fossil fuels since 1750, considerably slowing global temperature rise. But the forces that govern how much CO disappears into the deep every year are unknown. The early 1990s saw a jump in this sponge-like capacity, followed by a significant slowdown until 2001, raising concerns that the ocean may not be able to help us out forever. Drawing on both existing knowledge and ocean data that only recently became available, new research published this week in the journal Advances identifies two major influences on how much CO the oceans absorb every year: the rate of industrial emissions, and the global impact of volcanoes. The pace of fossil fuel combustion itself helps determine how much CO the ocean draws down. This finding presents a challenge to countries and companies managing pollution. As the world attempts to cut emissions to zero by 2050, which scientists say is necessary to avoid utter catastrophe, the ocean's ability to store CO will diminish with it. That complicates estimates of how quickly emissions will have to fall. We're stuffing all this carbon into the ocean. Every year we're pushing harder and harder and harder. And so the ocean in response is taking it up, said Galen McKinley, professor of Earth and Environmental Sciences at Columbia University and the study's lead author. But when we stop pushing so hard, the ocean is going to stop taking it up. On the 15th of June, 1991, the 20th century's second biggest volcanic eruption occurred when Mount Pinatubo in the Philippines blew ash 22 miles high into the atmosphere. Resulting cooler sea surface temperatures improved conditions for storing CO, at least for a short time, explaining the brief early 90s expansion of the ocean's carbon sink capabilities. 6 months later, the collapse of the Soviet Union in 1991 and energy efficiency improvements elsewhere led global CO emissions to slow down in the early to mid-90s, causing the subsequent contraction. Before now, scientists who looked at the problem attributed the ocean's strange behavior in the 1990s to changes in water circulation or how the atmosphere and ocean exchange gases, said Sarah Micallef-Fletcher, an atmosphere and ocean scientist at New Zealand's National Institute of Water and Atmospheric Research. McKinley and co-authors have shown that the story may be a whole lot simpler than that, she said. Their model suggests that the changes in the ocean carbon can be explained by two things: the amount of CO in the atmosphere and temperature. Climate science is dominated by extremely complicated, often government-built models that take weeks or months to run and analyze how key features of the Earth system affect each other. But McKinley's work is striking for the relative simplicity of its findings. The core of the research came from an insight McKinley had following meetings a couple of years ago with the Global Carbon Project, an international collaboration that estimates and tracks CO emissions. Rather than simulating the 1990s climate on their massive model, she realized she could use a short mathematical description of how the oceans work. It's kind of surprising. It's a very simple, theoretical, single equation, McKinley said. It runs in less than a second on my laptop and is able to replicate that behavior. That simplicity has a cost in terms of the model's predictive ability, as it doesn't factor in simulations of natural processes that might help scientists project how the ocean carbon sink could respond to climate change, Micallef-Fletcher said. Still, with further research, the findings could influence how nations understand their goal to limit global warming. The ocean is so responsive to pollution that its likely waters absorbed less CO this spring than they did before COVID-19 caused nations implemented quarantines. If we cut our emissions for controlling climate change, that ocean sink is very rapidly going to slow down, McKinley said. And that change will happen quickly. The result, according to Matthias Hoffman, a senior scientist at the Potsdam Institute for Climate Impact Research, means that humanity will need to step up its plans to slash emissions. Humanity has to compensate for this effect with even higher efforts, he said. Please save the trees and nature. Please subscribe my channel. Thank you.